In this video, we're going to acquire some high-resolution elevation data and a bare earth hillshade map from OpenTopography.org. Now I'm counting on you to use the pause button and navigation slider on your video app when you want to read or review the contents of this video. First, we navigate to the OpenTopography.org site and we look for the data menu here. Click on it. If we don't already know the data set that we want to extract data from, we can look at their interactive Google Maps style map powered by ArcGIS, on which all of the data set's extents are mapped out for us to select. I already know the data that I want, so I'm going to go straight to the data catalog. I'm going to make my life easier by selecting what state I'm working in. Okay. And I already know the data set that I want. It's the 2014 Tahoe National Forest lidar. I can use one of their differencing products at OpenTopography.org or pull down the point cloud, but I'm going to go straight for the raster data. So here's where I first encounter the data from the Tahoe National Forest lidar survey of 2014. It's mapped out on this little map, and I'm now going to tell OpenTopography exactly the part of that data set that I want to sample. I manually enter the selection coordinates here: x minimum, y minimum, x max, y max. I can just start typing in the data: 745,933, and you can type it in. I like to actually have all of the data in a data file off to the side so that rather than making typing errors, I can pull the numbers in directly and cut and paste. So that's what I'm going to do. As soon as I've got those coordinates in, I can validate the coordinates, and you can see that that's the area centered on Boca Hill where we're going to pull up our elevation data. Second thing we need to choose is the data output format. We're going to choose ASCII grid. The next thing, I want to make sure that the digital terrain model is checked. The digital terrain model gives me a bare earth hillshade map and the corresponding data. Visualization, we're going to ask OpenTopography to produce the hillshade image for me, at least the initial one. We're going to choose to have the artificial light from an elevation of 30 degrees and coming in at an azimuth of 130 degrees from the southeast. We're going to skip number 5 and go to the job description. It's going to be DVF for Dog Valley Fault. Panel number 54 is the one that we're going to do today. And then I just add the elevation and azimuth numbers just to help myself out. I can type in a job description if I want. And very importantly, I need to put my email address. That's where the data links will be sent once I'm finished with the job. Now I'm going to hit the submit button, and but I'm going to pause the video for a moment so that we don't use up too much time as it's thinking about giving us the data. So let's hit the submit button, and it's off and running. It takes a little while, but it has pulled down the DEM results and put them into a compressed file that is 129.4 megabytes in size. Now it's working on creating the hillshade image, so I'm going to pause it again and we'll be back as soon as it comes back. Okay, the visualization product is now back, and we can start making sure that we've got all of these files on our computer. One thing I like to do is download the job metadata. There's a little link up here. It says download job metadata. You click on that, and a file is sent to your computer, and it's got the dataset name, the acknowledgments that you need to cite in a paper, and then all of the details of the processing job that I've had Open Topography do for me. So that's now in my computer. The next thing I want to notice is the visualization of the hillshade image. I can just click on that and it will expand in the screen. It's moving a lot of data, so it takes a bit to do that. Now we can just take a look at this beautiful image. It obviously has a lot of things going on. There are roads, there are rivers, there are buildings, there are dam structures. I can take a peek at things a little bit more closely. Here's a pit, a borrow pit, gravel. You can tell that this is a street, and it has some houses that have been extracted pretty much from the image because of the bare earth algorithms that are used to strip away things like that. At any rate, good stuff here. So we're going to close that image. Now I want to get this image into my computer, so one thing I'm going to do is I'm going to download that linked file. I'm going to give it a name that's recognizable. DVF panel 54-hillshade, and it's off to my desktop. And the next thing I'm going to do is I'm going to click on this download compressed raster results link. And as soon as I click on that, it's going to take a little while for that thing to download, so I'm going to pause the video and let that happen. So it's on its way. Okay, everything's now been downloaded to my computer and this job's done. It took about 82 seconds for Open Topography to do its work, and it took a little bit of time for me to download the results onto my computer, but all in all, this is a pretty quick process, and it's a pretty amazing process given the amount of data that's getting shoved around. So if you have any questions or issues, would like me to help you out in some way understanding the material from this video, please give me an email message and I'll see if I can get back to you. Thanks.